All right, this time I'm going to go through two arguments where the conclusion is a particular claim, a sum claim, and an existence claim, and take a look at how to check for validity. Also just practicing diagramming the premises here as well. Everything in total, by the way, is listed in bold on page 35 to 36, and that's surely very important to take a look at that as well as everything else in the book. One other side note, I would recommend just working with the modern interpretation first. Do the first two sets of exercises. Maybe even you want to go ahead and work on the third and fourth set of exercises without thinking about how things might be different with Aristotle's existence assumption or assumptions. Okay, let's go ahead. Problem to the left. I just went with the argument in logical form again, some A or not B, no A or C, with the conclusion some non-C are non-B. Another side note, you may be able to think about intuitively whether or not a given argument is valid. Even if you are somehow perfect intuitively, it's good to have this technique to be able to prove things. And, you may not be perfect intuitively either, and most of us aren't. So, especially when we get to things particularly complex and sometimes differently subtle, and that can happen with some of these things. So that's another reason it's good to have the technique. Okay, I'm going to put a little side note over here to always shade first. In both of these arguments, we need to actually do the second premise first. It just makes the diagrams cleaner and clearer. That's the reason to shade first. Okay, back to black here. All right, so I want to diagram no A or C. No A or C says to shade out the A's that are C, areas 5 and 6. That looks like that. And then we have some A are not B. The A's that are not B are in areas 2 and 5. We don't have anything in 5, and so our mark goes just in 2. This would have been different and confusing if we had not shaded first. What we're doing is showing how the premises rather fit together. Okay, now we just got to take a look and see if we're guaranteed that some non-C are non-B. And indeed we are here. This is going to be a valid argument. We're looking for an X, an indication of some particular thing that's not a C and not a B. The X here is outside of the C circle, the purple circle. It's also outside of the B circle, the blue circle. So indeed it's a non-C, that is a non-B. It also happens to be an A, but that's really not relevant here. In total, the non-C's that are non-B are areas 1 and 2, and we do have something that's fully contained within those areas, which is our standard here. If it's an existence claim for the conclusion, we need to mark that it's completely contained within the area that corresponds to the conclusion. All right, let's go ahead and move on to the second problem. Again, we want to begin with our all claim here, since that's the shading, and we want to shade first, all A or B. It says to shade out areas 2 and 5. So I'll do that first. All right, knock that off. Yep, should have noted. Let's diagram the second premise there. Make sure you don't diagram the conclusion. That would make any argument valid. All right, some B or C. B's that are C are in areas 6 and 7. So we make a mark between those two areas. Neither one shaded, so we have to span both of them. And then we're asking if this guarantees that some A are C. The A's that are C are in areas 5 and 6. And we have something that goes into area 6, but going into an area means maybe it's there, maybe it's somewhere else. So in other words, we have something in 6 or 7. That doesn't guarantee we have something that's both A and C that's in the area 5 and 6. We're looking for a mark. I'm going to go ahead and draw it out in black, and the A's that are C in this particular area. Mark not totally contained within the area, so the argument is invalid.